everyone. I am Samarth Sikand. I work at Accenture Labs and have been working there for past 7 to 8 years. I work primarily in the area or at the intersection of AI and software engineering. Today I'm going to present our paper, How Much Space Do Metrics Have in Generative AI Assisted Software Development. So as we all know that LLMs are exploding around us everywhere, and back in 2020 when GitHub Copilot was released like in a beta mode, and there was a huge waitlist, and I joined that waitlist and got kind of access after 1.5 months of waiting. But at that point of time, we had a very few AI-powered code generation tools. Most like Tab9 was there, Copilot was there. There was a tool called Kite, which is now defunct. But since then till today, we have seen a lot more such AI coding assistant tools that have come into the marketplace, like Code Whisperer, StarCoder, AlphaCode, CodeLlama, GPT. All of these models are now kind of changing the way how we are approaching software development in a manner, and it's kind of defining the next generation of software engineering. So Copilot has more than 1 million developers, million paying subscribers, and according to a tracker, there are 50 or more such LLM-powered coding tools that are available right now in various forms with various licenses. So along with along with this growth in the LLM coding tools that we are seeing in the marketplace, we are also seeing a huge growth in the research that is happening around evaluating such LLM-based coding tools. And there have been many papers and research that have kind of focused on the functional aspects or the functional correctness of these LLM-based tools on certain tasks. Some have focused on the security aspects of it, whether LLM is or the particular coding tool is generating secure code or has any vulnerabilities present in it, and some are focusing on the usability aspects of it, how satisfied the developer is, whether it's readable or not. But as we have conducted this small survey around the evaluation of such studies, we have found a few potential problems. One of them is that there is a lack of standardization and categorization of these evaluation studies. We have found that there is some biasness in the studies towards some study designs and towards certain tools. And lastly, there is a huge variance in the metrics that have been used to evaluate these models to answer their particular research objectives in their particular studies within some of the productivity dimensions. So how do we tackle this problem? So this is where we have contributed our work. So firstly, we have tried to analyze all of these studies that are out there in the research, which are kind of targeted at evaluating such AI-powered code generation models. We are trying to highlight the differences and the commonalities in the study design across these studies. And we have attempted to standardize the metrics that have been used in these studies based on a popular developer productivity framework. Also, we highlight some of the potential gaps that we have found in the studies, and also provide some recommendations which will help in conducting future work. So now I briefly describe what is the developer productivity framework that we are using. So there's this paper from researchers from GitHub as well as Microsoft Research called Space for Developer Productivity. So this has laid down 5 dimensions which kind of encompasses the whole approach around capturing the developer productivity and the experience. It's a holistic framework that they have come up with. The first dimension is the satisfaction and well-being of the developers. So how fulfilled the developers feel in their work and how it impacts their work. Second is the performance. So the performance is best evaluated in terms of outcomes rather than the outputs. Like if you talk about whether the a developer is generating good quality of code, and the team is generating good, reliable, creating reliable products, and the features is leading to some kind of a cost reductions and so on and so forth. And then we have activity. Activity is the actual count or the actions of the outputs that are completed in any process or any, while building a product. Then we have communication and collaboration. This captures how people and teams communicate and work together. in a team dynamic. And lastly, we have efficiency and flow. So this captures the ability to complete the work or progress with minimal interruption. So when we talk about the zone or developer goes in while writing a code where he is totally uninterrupted and he feels very productive, so that is the flow that they talk about. So this is the pipeline that we have taken for our study. So we have these databases that from where we have collated the initial corpus of our research studies. So we kind of put in some queries in the digital library, Explorer, Direct, Science Direct, and everything. And then we got some few, I think 60 around some papers from which we shortlisted only those papers which have done some kind of a controlled user study or kind of a developer study within those works. And from that, we have shortlisted the metrics that have been used within those studies. And then once we had that corpus of the metrics, then we fine-tuned some of the metrics in terms of grouping whether, two metrics with two different names that are capturing the same intent might be used in different studies. So we have manually tried to fine-tune and group those metrics together. And then once we did that fine-tuning, then we bucketized or categorized those categories based on the space framework, which means that we assigned each of the metrics to one of the 5 dimensions mentioned in the space developer productivity framework. And then on top of that, we did a fit gap analysis and further analysis to see what kind of metrics researchers have been using in the using in their studies, and any gaps or any specific insights on top of that. So this is the overall summary findings of our of the work that we did. So we reviewed 17 developer studies and we collated 46 such metrics after the fine-tuning part of it. And some of the metrics that we have categorized in these 5 categories. Let's suppose for satisfaction, we have cognitive load; for performance, we have pass at K; acceptance rate; for efficiency, we have task completion times, and so on and forth. So at an average level, we have like 11 to 12 metrics in each of these dimensions. We have 0 in collaboration, which is one of the gaps that we'll highlight further. So some of the observations was that, I'll come directly to the trends, what we found. So some of the observation is that if you talk about the metrics that a particular dimension might be related to, so we see good number of metrics associated with satisfaction, performance, activity, and efficiency. But in all of those studies, we haven't found any metrics which captures the team dynamics of using generative AI tools in their entire process. So no study has been able to capture or has captured that the collaboration effect of using these tools. So we kind of also provide recommendations based on this, that the community should also attempt to capture the collaboration and the communication aspects of using generative AI tools, because in any enterprise settings, products and projects don't happen in isolation. It happens in a team, and there are various teams associated at every stage. So that effect needs to be captured. Personal, individual developer productivity, great, but team dynamics is also very important. Secondly, majority of the studies have been conducted using only 2 tools, or like more than 50% of the studies have only used GitHub Copilot and Codex, which is Copilot is basically a wraparound around Codex, which makes it kind of a same model. But 50% or more of the studies have been conducted using these 2 models only. So this leads to a point that if a study is trying to make some kind of a general statement regarding the usage of AI-based tools, it should be done after using a lot of those tools that are out there and models out there, to then create that general statement. Because if we create a general statement that AI does, leads to good productivity, great, but is that applicable to other models as well? Or if someone says using GenAI, Copilot leads to higher bug, is that applicable or is that generalizable across all other models as well? So that can lead to a pretty wrong generalization statement, and that's why we propose that the tools used within these studies or different studies should kind of attempt to use at least some other tools that are out there that we are seeing right now. Copilot is a great tool, but we have a much broader horizon of tools than now present. And lastly, within each of those product dimensions or the productivity dimensions, we are seeing a lot of, so we see a lack of subcategories within those particular dimensions. So if after categorizing a particular metric to a particular productivity dimension, we also assign some kind of a subcategory to it as to what specific intent it is trying to capture. And what we have seen is that there is a lack of diversity or within those subcategory or the intents that it is trying to capture within a particular productivity dimension. So if we take about performance, a lot of these studies are trying to capture, understand the performance of these tools, or trying to understand the performance, how it affects the performance of the developer. But those metrics are aligned or trying to capture mostly the code quality aspects of it, which is great and very crucial. But there are other aspects related to performance which should be captured, like reliability and some other metrics that should be. So we see this trend across other productivity dimensions like activity and efficiency. And yeah, collaboration is already absent, so we cannot comment on that. Also, this kind of, we also see a lack of cohesion or the lack of uniformity in the metrics used across all of these studies. So which kind of hamper, the comparison between the different studies that have been occurring out there. It can lead to, an obstacle in comparing different tools that are kind of covered in different studies. So there should be some kind of uniformity and standardization in the metrics used to evaluate any particular dimensions of any particular model. Right. So these are the three major drawbacks that we saw in these particular studies. And this particular work is not without its limitations. So we have realized that there are some limitations to this work. First of all, there are many metrics out there which do not fall under the purview of space framework. Space framework is a purely developer productivity framework. So there are other metrics that that can be associated with project health and other such aspects that are equally as important. Also, some of the metrics we felt had an overlap between different dimensions, but for the purpose of this study, we have kept those categories or kept the categorization mutually exclusive. And yeah, so, and also wherever we felt that it had multiple overlaps with different dimensions, we assigned it to the dimension which we thought was the highest degree of overlap it was having it with. Then, so finally, in conclusion, so the aim of this particular work was to promote the understanding of how evaluation of LLM-based tools, models, coding tools are evaluating in the research community. We have only focused on evaluating the studies which have some kind of control user experiments or developer studies in those works. We have tried to align and standardize the metrics that have been used based on the space framework. And for future work, we are going to expand or broaden this particular framework that we have to encapsulate more dimension, more aspects apart from space. And also we'll try to kind of allow for more sophisticated kind of categorization, and it will allow for multiple multiple overlaps over different dimensions. So yep, that's all from my side. Thank you.
Any questions? Yeah, please.
Hello. Yeah, I was just wondering whether you considered
and whether to call it metric or not, I don't know, but it falls under your satisfaction category. That a developer typically, at least when MD came into the picture, one of the observations we had was the developers were a little circumspect, and they were worried that they would lose the experience of learning programming, because they thought they would only be writing models and code generation would happen. With LLMs, it gets abstracted to a further higher level of abstraction to express specs in, let's say, natural language in terms of prompts or whatever. So is that a metric in terms of the developer's fear, or I don't know how to concretize it, but is that a metric that you would want to consider, or you considered speaking?
Yeah, I mean, in this particular work, the metrics that we came across is especially with respect to satisfaction. So the metrics that they were trying to, the studies have tried to capture is basically, do developers feel more satisfied or less satisfied after using generative AI tools, right? So none of those studies we have come across have tried to address the concern that you are raising, that whether they will be able to learn coding in a way that has been happening, right? So yes, definitely, if we do come across such metrics, we'll include it in our framework. Yeah.
See, just to follow on a small comment, it's not just about the programming aspect, because I think if the prompts have to improve in terms of specific instances of the prompts or generic prompts, that's what typically it would happen based on how LLMs have evolved, then people really have to know what is a good program in order to get it generated.
Agreed.
So it's not just about satisfaction, but also about the quality of what comes out as output, and for that they have to know what is that quality. What is the good quality.
Yeah.
So in that sense, I thought it's something could be important to consider as a metric.
Yeah, definitely. Yeah, we'll consider it.
So regarding this collaboration aspect, that is the interesting point from your talk, right? Like usually collaboration in office is measured like usually with GitHub repository activities. Like I give my code for review, someone reviews, this is what is treated as collaboration. Yeah. But now when you want to, let's say, really measure collaboration, how it is increased using these tools, I mean, based on your experience, what do you suggest, like how to go about it?
So if we just go by the definition of collaboration, and that it has something like, code quality reviews by our peers within those teams, whether if they are good, then I would say that that's a good indication of increased collaboration between the team. Other such metrics can be like, I think how fast the integration of different people's work is happening. I think that's another metric that can be used to measure the collaboration aspects within a team. So all the different developers within a team, their work have to be integrated at some point of time. How fast that integration is happening? Are there more obstacles, less obstacles in integrating that work? So those metrics, I think, can be that come in the collaboration aspect of it.
Sure. Let's, yeah, please.
Yeah. Yeah.
So how does this help to integrate with the legacy code? How seamlessly it helps to integrate with the legacy code? And the second question is, what is the impact of this on, maybe you talked, but I missed, on bugs? I mean, do bugs count go down? Or because you use this kind of tools, right?
Yeah.
So eventually because testing will still happen. People will still test the software, right? By simulating it and other things.
Right.
Does the bug count goes down, or bugs still continue to linger?
Now, can you just repeat your question?
Softwares will have bugs, right?
Right.
Correct?
Yeah.
So if I use a tool to generate my code and seamlessly I integrate it.
Okay.
Correct?
Yeah.
It's a general purpose tool, right?
Yeah.
Okay.
Yeah.
I test those systems.
Yeah.
Do I discover more bugs, or my bugs count also go down? I mean, in terms of these metrics, is there any data that, okay, most of the times the code which I get is correct? Mm-hmm. Okay, it is free of bugs?
So there have been different, I would say, if you talk about that, like which metric captures that, like whether the bug count has increased or decreased. Some studies say that bug count does increase. It adds to more cognitive load to the developers. Those studies mention out there. But some studies also mention, so we have observed a very counterintuitive thing. So developers feel more productive, but also in our internal assessments, we have seen that it produces more buggy code. So I mean, like it's a kind of a counterintuitive thing that like productive developer feels productive, but it produces more buggy code. So how do you resolve that? How do you come in terms with that? That is still in study.
And also, every organization will have a structured way of coding, right? I mean, they will have their standards, processes, and other things, right?
Yeah.
Now, does it follow those things, or does it train to follow those things? I mean, I'm not aware of these things.
In the studies that we have evaluated, it does try. Some of the metrics are like coding style adherence. So they might capture a particular way of an organization trying to code, right? So those metrics are still there. I mean, they are being captured in the studies, but like we need to go more into those particular studies and see how it increases or decreases that we have to check.